For lesson 12.5, you are calculating the volume of prisms and composite figures. Again, I'm going to stress the importance of showing your work and not just relying on your calculator to type in the numbers and just write down the answer. I'm going to be working out problems 18, 19, and 22 from pages 583 and 584. Please make sure to show your work on your note sheet as I have done in this video. For number 18, I went ahead and color-coded a couple things here. We have a candle that's in the shape of a triangular prism. So that's what we have shown here. And so you'll see that I've started off with the formula for a triangular prism, which is volume equals capital B H. And that capital B is important. It's not the same as a lowercase b as we use in the formula for the area of a triangle, because volume, the capital B, is going to change depending on what the base is. In this case, the base is a triangle, so the capital B is going to be the area of a triangle formula, which is 1/2 base times height. And then I'm going to multiply it by the height of the whole prism, which is where that extra h comes into play. Okay, the next step, I'm going to just transfer all the numbers or substitute in the numbers that I know. In this case, 1/2 is a constant there. The base of the triangle is 3. The height of the triangle is 2.6, and then the height of the prism is 5. And then it's fine to use a calculator to double check your work and type it in at least twice to make sure you get the same answer twice. The volume of the candle is 19.5, and that's cubic inches. I just didn't label it yet. For the second part of the problem, we have a rectangular box, and it gives us the measurements of 3 by 5 by 7. So in this case, I also started with V equals capital BH, but that capital B then is going to be the formula for the area of the base. And since we're talking about a rectangle, we're going to use length times width. You might already know that volume equals length times width times height, and that works for all rectangular prisms. But technically it is the capital BH would be the formula, and then you substitute in whatever that base's area formula is. So in this case, it's just a simple multiplication of 3 times 5 times 7, which works out to be 105. And since it says it wants to know the volume of the foam pieces needed to fill the space in between the candle, we're going to take that total, 105, minus 19.5, which is the candle, and we should get our final answer of 85.5, 85.5, and it is measured in cubic inches. So they're going to need 85.5 cubic inches of foam to surround that candle in that box to keep it safe during mailing. Okay, make sure you get all of that on your note sheet for problem number 18. For number 19, we have a word problem, no picture, so I highlighted a couple of things. It's a triangular prism, so I started with the formula V equals capital BH, but that capital B then translates into 1/2 base times height for the triangle. It also tells me that the height of the prism is 8 feet, so that's where I substituted in the h there for the height of the prism. The volume is 200, so I substituted in 200 for the volume. 1/2 is a constant, and then it says that the base has a length of 5 feet. So here we have this 5. So in this case, we are wanting to isolate the variable h to find out the height of the base. And so we're going to first of all simplify 1/2 times 5 times 8. I can take 5 times 8 first, which is 40, and take half of that, which is 20. So what I end up with is 200 equals 20h, okay? And then if I want to isolate that variable h, I can divide both sides by 20, divide by 20, and then I get that the height, if I cancel out a common 0 there, I get the height is 20. And we are measuring in feet, so the final answer is 20 feet. Actually, it is not 20 feet, it's 20 divided by 2. I not only canceled out a common 0 there, but I needed to simplify 20 divided by 2, which is 10 feet. Sorry about that. The final answer to number 19 is 10 feet. Okay. Moving on to the final problem for lesson 12.5. It's number 22. And on 22, we have a composite figure composed of two rectangular prisms and then two triangular prisms and then a rectangular prism in the middle. So you'll notice that I color coded once again. These triangular prisms on the side are going to be calculated by using volume equals capital BH, but of course the capital B translates into the shape of the base and the formula for that shape, which is 1/2 base times height for the triangle. And then we also multiply that by the height of the whole prism. So in this case, we have a base of 3, we have a height of 3, and then we have a length of 7. So 3 times 3 times 7 times 1/2 gives me a volume of one rectangular prism, which is 31.5, but of course we have this one on the right and this one on the left. So times it by 2 and we get a total of 63 cubic centimeters. For the rectangular prism down the middle, we have capital BH, or if you just want to write down length times width times height, that's fine. We have a length of our rectangular prism as 5, and we have a width of 3 and then a height of 7. And you might not use those same words, length, width, and height. In this case, it really doesn't matter if I take 5 times 3 times 7 or 3 times 5 times 7 or 7 times 5 times 3. The commutative property says I can multiply in any order. I'm still going to get that 105 cubic centimeters for the total of the rectangular prism. Now, if I just want to add those two together to get the composite figures total volume, I will just add those together to get 168. And we do have a measurement of centimeters, and volume is cubic. So 168 cubic centimeters is the total volume. Make sure to show your work. Don't try to cut corners by just using your calculator. Show your work, show your steps, and then it's easy to go back and check to see where you made your mistakes if you do make any.